In this video, I'm going to go through one question about chi-square testing. Hopefully this question will include all of the things that you are expected to know and all the things that might be asked for you. There are certain things that they might not ask in some questions, but I've included all of them in this question. So this is extracted from Math Studies book developed by the IB diploma, and it asks to go through the chi-square testing. So Evelyn hypothesizes that political affiliation is dependent on gender. She collected data by randomly selecting 18 names from the phone directory. Evelyn organized the data in the contingency table below. So we have all the information here, and you can immediately see that you have two sets of data, and these are the results of her the questionnaire she did. So the first question is always, or typically, state the null and alternative hypothesis. The null hypothesis is usually written with an H subscript O, so HO, which is the null. So you can write either a null hypothesis or H subscript O. Zero, sorry. And the null hypothesis is basically you stating or trying to test, the hypothesis you're trying to test, is that these two are independent from each other. I know everyone's trying to test that they're dependent on gender, but null hypothesis is typically when you have two data sets and you want to test their independency. So you say that the political affiliation is, and then I'm just going to do it in red, independent of gender. Really easy to do. And then the same exact sentence for the alternative hypothesis, which we write as H1, except that instead of writing independent, we write dependent. Now, some of you might write not independent. You could, but it's just too many words to focus on. So political affiliation is dependent on gender. Okay, so this is what Evelyn's trying to test, the alternative hypothesis, but our null hypothesis is that they are independent. So it doesn't matter what the gender is, your political affiliation will not be affected by that. So in general, if you're doing your IA, or if you are, if you're comparing two different data sets, we tend to use correlation coefficient to see how are the two data sets related. But correlation coefficient doesn't necessarily tell you that the two data sets are dependent on each other, or do they cause each other. Two things might have a strong positive correlation, but it doesn't mean that they necessarily affect each other. So this is where chi-square testing comes in place, and it's really powerful to do because you can actually tell if two things are dependent or independent from each other. So this is usually the first question, state the null and alternative hypothesis, really easy to do. Next questions are usually Part B's are usually about finding the expected number. So expected number is when they want you to find values that you are expected to find if the two data sets are independent. It's a bit of a complicated definition. If you're not comfortable with knowing the definitions, you can skip ahead, but it's trying to balance out all these numbers so that realistically, or in theory world, all the males and the females will pick an equal, will have an equal spread through Democrat, Independent, and Republic. Now, you will not be expected to do the whole expected table, expected frequency or expected value table. You will have to do it for your IA, but not for questions, unless it's a really long question. They will tend to ask you to show that the expected number for a specific two sets of data is something. So for this question, we have the male Republican. So we're looking at male and we're looking at Republican. So we're looking at this box. Another thing to note is that you need to forget about these numbers when you're looking at expected value. what you need to find first is the totals for each row and each column. So the total for the males, which is 14 plus 3 plus 23 is 40, and then the total for female, 21, 6, and 13 is also 40. So you need to find the totals for the table. So I'm just going to label this as total. And then you also need to find the total for each column. So the total for the Democrats is 35, Independent is 9, and Republican is 36. The last thing you need to find is the total of the table, which should add up to how many people you have. So she asked 80 people, and it should add up to 80. So this should add up to 80, this should add up to 80. If they didn't, then something went wrong. Now, when you're looking at expected number, you always take the total for the row, multiply the total for the column you're looking at, and then you divide by the total of the table. Now you can look at this formula as a formula for finding probability. So if you're more comfortable, you could do 40 over 80 times 36 over 80 times 80, and things will cancel out. But I find this much easier to look at. So if I'm looking at male and Republican, because I'm looking at the male section, I'm going to take the total for the male. So that this is my total for the row. And then because I'm looking at Republican, I'm going to take the total for Republican, so 36. And then I have the table total, which is 80. And I'm going to put it there, and it should give you 18. If I wanted the female independent, I'm looking at this square, so I'm going to take the total for the female, which is 40, total for independent, which is 9, 40 times 9, and then divide by 80. That's simply what it is. So finding expected value is quite easy. You might need to create a separate table, but the first step is to find the totals for each row and column in the table, and then note which value are you expected to find. Ignore the numbers inside. You won't be using these numbers. You will be using the totals though. So we do expect, if the test was fair, we do expect to have 18 males that would pick Republican. That's what it basically says. So we are expecting 18, but we actually observed 23. So that's the role of the expected number. Now you can put this in your calculator, and it should give you the answer. You can put this in the matrix, and it can give you all the expected values in matrix B. I'm going to show you that later on. So this is for the expected number. Then degrees of freedom, quite an easy part, so hopefully you won't lose marks on this. For degrees of freedom, remember that you need to ignore the total columns and rows. Okay, you are looking at your original table and how many data sets you have in each. So degrees of freedom, you take row number and then you subtract by 1, and you multiply by column number and you subtract 1. That's it. So how many rows do I have? I have 2. I don't have 3 rows. Keep in mind that this is the label. So I only have 2 rows. I only have the male and female. So that's 2 minus 1. And then the column, I only have 3 data sets for the column for the political affiliation. So that's 3 minus 1, 2 minus 1, 1, and then times 3 minus 1, which is 2. So my degree of freedom is 2. And that's it. That's all you have to do. Quite easy. The next questions usually ask you to find the chi-square value. I didn't write it in symbols here, but usually they won't write chi-square. They'll actually write chi-square calc. So you need to calculate the chi-square value. For the chi-square value, what you have to do is you need to input this data into your matrix. So all of this data, 14, 3, 23, 21, 6, and 13, you need to input this in your GDC. If you're doing your IA, you'll have to actually you'll have to do the chi-square value separately on your own. So going through this really quickly, so you go second, matrix, which can be found just above the x to the power of -1 or d. And then you go to edit. So you want to edit a matrix. Then you write the size of your matrix. So you have a 2 by 3 matrix. So I have a 2 there already. I have a by 3 matrix. I'm just going to change the 4 to a 3. And it should change your table. If you got the wrong numbers, it's probably you swapped these two numbers around for the rows and columns. So you just swap them around. I'm going to clear each value and write my proper values. So you enter, clear it, enter 23. You don't use the expected value in your calculator. You need to input your observed value because the calculator will do the expected value for you. Now, once you're done, because you're doing statistics, you're doing a test, so you go to stat. Data, you don't need to do anything after that. So stat, and then you go to test. You can scroll down until you get to option C, which is chi-square testing. So just there, chi-square testing. Your observed will be an A. Expected, just leave it as any other matrix than your observed, so they have to be different. So they're going to find the expected value for you. Now, if this is cleared, or if you wrote your observed value in a different matrix, then just press on second, and then matrix again, just as we did in the beginning. But don't go to edit, just stay on names and select which matrix you've actually edited. So I have matrix A. And matrix B will change automatically to have the expected value. And then you go to calculate, and you have the chi-square value is chi-square value is 5.178. Okay, be careful with rounding here. You can also see that the degrees of freedom is 2. Now, this is the chi-square value. The last part of the question is to complete a chi-square test at 5% significance level. Critical value is 5.991. Using the chi-square value or the p-value, comment on the results for the test. Now, what you have to do is compare your chi-square value to the critical value. So the chi-square value was 5.178, and I have the chi-square value, which is 5.991. Now, since the critical value is bigger, so I'm just going to do that, because the critical value is bigger than my chi-square value, the conclusion is, which is you answering comments on your results, we do not reject the null hypothesis. So basically what we're doing here is we don't necessarily accept the null hypothesis, we just fail to reject the null hypothesis. And so if you want to conclude even more, you can say, so the political affiliation is independent of gender, or we have enough reason to conclude that this is so, even though that the values are quite close. You can pick different significance levels for your IA, but for this question, it's already given for you. Critical value will always be given, and significance level will be given as well. Now, if you're not given the critical value, you will have to use the p-value for comparison. You can also use the p-value to actually double check your answer. So for p-value is found from your calculator, and it's 0.0751, 0.0751, and your significance level, you compare your p-value to the significance level, whereas you compare your chi-square value to your critical value. So significance level, the significance level is basically taking this 5% and then just changing it to a decimal. So 5% is the same as 0.05. I just divided it by 100. And then if I compare these two values, you'll notice that the p-value is bigger. And this also means that if the p-value is bigger than your significance level, then you, again, do not reject the null hypothesis. So the conclusion has to be the same. So we don't reject null. And that's the conclusion you should come up with. So just keep in mind that the comparison for chi-square and p-value are slightly different, but the conclusion should be the same. If you're not given the critical value, you'll have to use the p-value. And it's good to use both of them for your IA just to double check.